Good afternoon, everyone. Hi there. Welcome to this session of Carbon is Key on future aviation. My name is Fiona Smith, and I'm the Group Head of Aerodrome Strategy for AGS Airports. And our airports are Glasgow, Aberdeen, and Southampton. And I'll be your chair and your host today for this session. I come into you today in Glasgow, so host city for COP. So really privileged to be hosting this session with the sort of monumental occasion that it is for all of us of this event, and for the aviation industry also. So we've got some fantastic participants today on our panel. Just like to introduce them to you quickly. So we have Dr. Thomas Budd, a lecturer in airport planning and management from Cranfield University. We have Adam Morton, Head of Environmental Technology for Rolls-Royce. We have Peter Rafano, Environmental Intelligence Services for Envirosuite. We have Valentina, Vecchio, Sustainability Policy and Partnership for Boeing. And we have Will Wright, an A320 pilot, Young Air Pilots Chair for the Honourable Company of Air Pilots. So thank you so much to all of our panellists for joining us today. Really looking forward to speaking with you and hearing your presentations. So before we get started, just to sort of introduce the format of today's session. So we'll be hearing from all of our panellists, but we really encourage an kind of interactive session. So shortly you'll see a window on your right, which will allow you to post questions or comments to any of the speakers at any time on the stage chat area. And our intention is to be able to come to all of your questions. So if you can post them, that would be great. You can also communicate in this section in private or in public if you wish, in groups of up to 6 people using the front row networking tool, which will be at the bottom right hand of your screen. So to move to our first speaker, Head of Environmental Technology for Rolls-Royce, Adam Morton guides an annual investment of around 800 million to deliver improved environmental performance across aerospace and non-aero products and services. He has a variety of senior technical and business roles in Rolls-Royce, including Head of Innovation and Chief of Low Carbon Technology, and was part of the team that established and led the Energy Technologies Institute's 600 million public-private sector collab. Adam, if I could hand over to you, I think you're going to talk a little bit around fuels and propulsion.
I am, thank you, Fiona. As Fiona said a few moments ago, I'm Head of Environmental Technology for Rolls-Royce, and a large part of my job is deciding from the range of possible opportunities for making our products more sustainable, how I allocate time, or how we allocate time and effort across those different opportunities. And hopefully by the end of this 15-minute or so presentation, you'll have some idea of the sorts of technology and fuel opportunities that are available to the industry, and the kinds of factors that we consider when thinking about where we allocate our interests. First slide, please. Next slide, please. Thank you. So in decarbonising aviation, Rolls-Royce takes a 3 pillars approach to addressing the problem. The first of those pillars is improving the system efficiencies, and certainly on the aviation side at the moment, that's very much in terms of improving gas turbine efficiency. This is important because large aircraft flying transoceanic and transcontinental distances are likely to continue to rely upon use of gas turbines with liquid fuels for some time to come. And by increasing the efficiency of those gas turbines, not only do we minimize fuel burn and hence fuel costs for the carriers and the operators, and hence improve the economics of their operations, but also, given the relatively low quantities of sustainable aviation fuel that are available at the moment, it allows us to make best use of those scarce resources. The second main pillar that Rolls-Royce looks to in terms of decarbonising aviation is to accelerate the use of sustainable aviation fuels, or SAFs. Having been operating our products on SAFs for about 15 years or so, we have a number of objectives, and those objectives I think have become more sophisticated and slightly more nuanced in recent years. Initially, objectives were very much around lowering the cost of those sustainable aviation fuels and driving greater scale. Increasingly, we're looking to those fuels which deliver much better overall life cycle CO2 benefits. At the moment, we think there's a considerable way to go as we move through the sorts of SAFs that are available now and start to move into greater maturity on those, but also new fuels coming through in the future. One of the things that's most exciting in SAF space at the moment as an engine manufacturer is the opportunity to understand some of the non-carbon benefits. So yes, they do deliver overall life cycle CO2 benefits, but we're already starting to see from the testing work that we're doing that they also deliver other benefits in terms of reductions in other emissions. So things like particulate matter, contrail formation, etc. And it's quite possible in the future certain SAFs will be able to deliver reduced costs associated with repair and overhaul of aircraft. And it's really this understanding these wider benefits that's one of the things that started to come into sharp relief in recent years. The third pillar of decarbonising aviation for the industry is to develop radical alternatives such as electrification and hydrogen. This is an area which you'll be aware of. Rolls-Royce undertaken work in relation to both hybrid, fully electric, but also the work that we're doing in the hydrogen space. Next slide, please. Developing the technology, as I've said, is an important part of delivering the efficiency necessary in order to maximise the utilisation of the SAF, or to optimise the utilisation of the SAF, but also to minimise the transition costs associated with the transition to net zero. In undertaking this work, one of the key areas that we've been looking to is development of the Ultrafine Engine. This is a technology that's in development at the moment. Back in March of this year, we began work building the world's largest engine, the Ultrafine. The engine with a fan diameter of 140 inches, or 3.5 meters, with the first module of this to be completed by the end of the year. The concept has potential applications both for wide-bodied aircraft, but also for narrow-bodied aircraft also. And why a key focus on an engine such as this in a piece about carbon? Well, simply because it targets a 25% fuel efficiency improvement compared with the earliest of trends. And with support from a variety of funding agencies such as the Aerospace Technology Institute, Innovate UK and LUFO of Germany, we've pulled together a number of key systems in order to deliver this game-changing improvement in efficiency. This includes carbon titanium fan systems, a powered gearbox, and to give you some idea of the challenges associated with the gearbox is rated at 50 megawatts. This is the power equivalent to 500 family cars. In addition to the carbon titanium fan system and the powered gearbox, we also have a new and proven advanced Core 3 lean burn combustion system and a composite casing to reduce weight by about 1,500 pounds on an aircraft basis. Coupled with new digital capabilities and manufacturing capabilities, we're confident that this will deliver game-changing performance improvements, both in terms of carbon, but also in terms of noise. And in order to test and fully demonstrate those, we've delivered a purpose-built £90 million test facility in Derby, the largest engine testbed in the world. Next slide, please. Thank you. Back in December of last year, Rolls-Royce successfully demonstrated use of 100% SAF on its engines, combining the Alexis lean burn technology. Even sourcing the necessary sustainable aviation fuel was something of a significant challenge and required collaboration. Production of the fuel was by World Energy based on a HEFA technology. The sourcing was by Shell Aviation, and the delivery was by Sky NRG. And the work demonstrated that we could operate our engines on 100% SAF, despite the fact that engines currently in the fuels are only at the moment certified for use up to a 50% blend. And secondly, it gave insights into how, by combining sustainable aviation fuels with lean burn and other technologies, it's possible to deliver not only improvements in NOx, but also it's very likely that we get additional benefits in terms of things like particulate matter. And since these can be closely related to the formation of contrails, there's possibilities for improvements in contrail formation as well. Weeks later, using the same fuel, we were able to successfully test a Pearl 700 engine, so a smaller engines associated with business aviation. And we ran this successfully on 100% SAF, giving confidence about future ability to operate at higher percentage blends and more confidence about the sorts of timescales that will be achievable with regards to certification at 100%. Next slide, please. The long-term target for sustainable aviation fuels is to operate at up to 100% blend, at lower cost than the current premiums that we're seeing compared with conventional jet A, achieve high life cycle CO2 benefits, and fully understand the non-carbon benefits, including sustainability and possible repair and overhaul benefits. But even though this would allow drop in use across all current and established aircraft types and ranges, current volumes of sustainable aviation fuels are relatively small. They're typically less than 1% of what would be needed if SAF would completely replace kerosene in the future, and electric aircraft, both hybrid and fully electric aircraft and aircraft powered by hydrogen, have a potential role to contribute towards the decarbonising of aviation, whilst at the same time not drawing on the same sorts of inputs and resources associated with the transition to sustainable aviation fuels. Whilst work in this area is developing quickly, and electric powered aircraft are already available, small hydrogen powered aircraft could materialise this decade. Larger hydrogen powered aircraft we would expect to see appearing from the 2030s onwards, and even at larger scale there may be possibility to have utilisation of hydrogen both in gas turbines and fuel cells, but this presents some quite challenging technical and materials issues to achieve that transition. Next slide, please. It is the opportunities in electric and hybrid aviation that have guided the sorts of decisions that we've made in terms of launching technology programs and forming collaborations with others. In urban air mobility space, or UAM, Rolls-Royce is set to power Vertical Aerospace's flagship aircraft. Here we will design the system architecture for the electrical propulsion system. This will include our latest 100 kilowatt class propulsion units, power distribution technology, but also the systems monitoring as well. We already have 150 Rolls-Royce engineers in 5 countries working on the project, and we would expect this to be one of the first UAMs to be fully certified. In addition to the work that we're doing with Vertical Aerospace, in parallel we're working with Electroflight on an all-electric aircraft targeting a speed of greater than 300 miles per hour. This Excel initiative aims to break, effectively shatter, the existing 210 mile per hour speed record for an all-electric design, and it is as well as driving imagination in terms of what is possible. this will play an important part in understanding the challenges of integrating the different systems together, but also driving the necessary supply chain for delivery of electric aircraft in the future, including supply chain in the UK. In more conventional space, we're also working with the Scandinavian regional airline Widerøe to deliver an all-electric passenger aircraft for delivery into service by 2026. Next slide, please. Thank you. In addition to working on a variety of different technologies, I've already mentioned more efficient engines, working to drive down the cost and increase the scale of SAF, and to better understand the wider environmental benefits. Rolls-Royce is also, as is much of the industry, interested in the use of hydrogen for decarbonising aviation. Hydrogen, for a number of reasons, is of interest, has 3 times the energy density of kerosene on a gravimetric basis by weight, and when it combusts, it only generates water vapour, and tends not to generate the same, to generate other atmospheric pollutants. But whilst its gravimetric density is 3 times higher than kerosene, it tends to occupy a large volume, and actually the volume, even under favourable conditions, can be 4 times the volume that's occupied by kerosene. The production and infrastructure is still lacking, and the high temperature associated with combustion presents technical and engineering challenges for people looking to, particularly looking to develop gas turbine technologies to utilise this new fuel. And at the moment, looking to be suitable mostly for shorter range aircraft and smaller aircraft as well. Whilst there are a number of challenges to consider, much of the debate associated with utilisation of hydrogen in aviation concerns the form of the hydrogen, whether it's in liquid or gaseous form, and also the conversion technology necessary for converting that fuel into thrust and power. As I've said, the 2 main sources are gaseous and liquid. Generally, gaseous is for shorter and commuter range aircraft. Liquid is much more of an enabler for larger aircraft. There tends to be a bias with gaseous hydrogen towards utilisation of fuel cells, whereas with liquid H2, the bias we think at the moment may well be towards gas turbines. The utilisation of gaseous hydrogen avoids the need for expensive cryogenic technology, but liquid H2, by contrast, provides opportunities for quite advanced thermal management opportunities, and also to take advantage of cryogenic superconducting opportunities as well. But both have implications for airport infrastructure and are likely to have implications for the need to invest in airports of the future going forwards. But even with some of the challenges associated with hydrogen, we're fairly confident that through the work of the ATI, FlyZero, and other organisations, many of which are doing work in the UK, and inputs from UK-based startup companies and also larger OEMs, we think as from next year we'll start to see a much better resolution of the sorts of issues associated with operation of hydrogen, whether it's from gas turbines or fuel cells. Thank you very much.
Thank you, Adam. Thanks so much for the presentation. Just maybe a question. So we had a poll running during your presentation, which was basically asking what the audience perspective was on what would have the biggest impact on carbon emissions, whether it would be aircraft and engine technology or a deployment of sustainable aviation fuels, and the sort of return was 67% believe that the wider deployment of sustainable fuels will have the bigger impact on aviation. So with that in mind, in talking about all the different types for SAF in particular, as an engine manufacturer, what do you think? What do you see as the kind of most exciting developments in SAF right now?
I mean, some of those I've already touched upon. The fact that we're starting to move away from a simple let's get the cost down and scale up, moving through let's get the blending limits up, let's get some life cycle CO2 benefits up as well. A lot of the work that's being done to evaluate the opportunities posed by different SAFs is starting to identify that in the same way there's no silver bullet to deliver decarbonisation. We need technology, we need SAF, we need airspace management, etc. It's rather the same. It's rather the same in the fuels themselves. The moment the principal source of SAF is HEFA technology, over time that will become limiting because it's reliant upon feedstocks of waste oils. We will start to move through HEFA and alcohol to jet, to gasification of waste and biomass with Fischer Tropsch. That will start to increase the scale of production going forwards, and then over time we'll start to see this transition from HEFA, alcohol to jet, and gasification plus FT to start to include other technologies such as pyrolysis. I think one of the most exciting ones at the moment is e-fuels and power to liquids, where you utilize low carbon electricity to electrolyze water. You generate hydrogen, and then you combine that hydrogen with a sustainable source of carbon to produce a fuel which is capable to be dropped into an engine. The beauty of e-fuels is you're not relying, or you're not competing to quite the same extent for the inputs, and we believe that it will produce a cleaner fuel which has potentially some advantages over some of the earlier SAFs that have been available.
Thanks, Adam. That's really interesting, and thank you again for the presentation. It was great to hear about some of the sort of wider things that Rolls-Royce are doing at the moment. The amazing Ultrafine engine that you're working on, and nice to see that it spans right down to sort of UAM type aircraft. So really exciting to see all that innovation in Rolls-Royce. Thanks again. Just a reminder to all our participants, everyone watching, please do ask questions of our speakers. You'll see it on the stage chat on the right. You can ask a question at any time and we'll pick it up. I'm going to move on to our next panellist, who is Dr. Thomas Budd, a senior lecturer and DARTEC fellow in the Centre for Air Transport Management at Cranfield University. He's also course director for the Masters in Airport Planning and Management, and both his teaching and research span a range of air transport management issues, from environmental sustainability, resilience planning, digital transformation, innovation, and the air passenger experience. Thomas is currently working alongside various partners, including Heathrow, Rolls-Royce, and GKN Aerospace on Project Napkin, which is funded by the UKRI Future Flight Challenge programme, and looks to develop a blueprint for the creation of domestic low and zero emission air travel in the UK. So, Thomas, if I can hand over to you, that would be appreciated. Thank you.
Thanks very much, Fiona. And good afternoon, everyone. And thanks very much indeed for the opportunity to speak at the event this afternoon. My name is Thomas Budd. I'm a lecturer at Cranfield University, and I'd like to talk today about a particular project that we are working on currently, our Project Napkin, and particularly looking at the airport infrastructure and operational impacts of zero emissions aircraft technologies, some of which Adam has just talked about. So if we could just go on to the next slide, please. Thanks. So it's a slightly unusual acronym for a project talking about aviation, but Project Napkin stands for New Aviation Propulsion, Knowledge and Innovation Network, and is being funded by the UKRI Innovate UK Future Flight programme. So we obviously acknowledge and thank them for their support. The project is currently ongoing, due to be completed in April of next year. And at Cranfield, we're working alongside a number of both in industry and academic collaborators. The project is being led by Heathrow, but you can see some of the other organisations on the slide along the bottom. And the aim of the project is that we are collectively taking a holistic approach to try and develop a blueprint for what zero carbon, so zero emissions flights, both pure and hybrid electric and hydrogen aircraft, so some of those radical technologies that Adam has just alluded to in his presentation, for domestic aviation in the UK. So we have a domestic UK focus. By holistic, we're adopting what we're calling the 5 A's approach. So looking at the perspectives from an aircraft manufacturer's perspective, but also from an airport operator's perspective, the operators of the aircraft themselves, so the airlines, as well as airspace and the air passenger perspective. And the project is covering, or aiming to cover, some of the research questions that you can see on the slide. The questions that we're looking at Cranfield in our work package relates to particularly the airport infrastructure and operational impacts of zero emissions aircraft, as well as aspects relating to what the likely operating costs of these new aircraft will be for airlines, and related to that, maintenance requirements as well with these new aircraft concepts. And of course, sitting above all of this relates to the safety management side of things. So looking at particularly at the safety related aspects of both the aircraft themselves and the systems that will support them. So if we can go on to the next slide, please. From an airport perspective, I think it's important to understand and think that in all likelihood, and depending on the focus of the airport itself, but there will be a multitude of potentially coexisting energy vectors here. So we have, on the electric side of things, we have both pure electric, pure battery electric aircraft, as well as hybrid variants. And then on the hydrogen side of things, we have both gaseous hydrogen in a fuel cell configuration, where the fuel cell is generating electricity to power the aircraft. For example, Cranfield Aerospace Solutions Project Fresson, who are part of Project Napkin. They are a partner on Napkin. That is the aircraft that they are working with. So they have an aircraft it's a Britten Norman Islander aircraft, which they have retrofitted with a gaseous hydrogen fuel cell configuration. Then you also have liquid hydrogen. So you have that both in a fuel cell configuration, like the test flights we've already seen from Zero Avia, but also as a direct fuel source as well in modified engine, so as a direct fuel source in direct combustion, like Airbus's Zero E concept. So we have a multitude of coexisting energy vectors for an airport to support. We think that the electric aircraft are likely to be generally smaller and generally shorter range, and I'll come on to the reasons why that might be the case in a moment. Whereas the feeling is that hydrogen offers potentially greater opportunity for potentially larger and potentially longer range aircraft from about 2030 onwards. I think it's important to note here that by longer range, we are not talking about long haul or ultra long haul flights at this stage. It's more about narrow body, sort of short haul international routes would be the focus for hydrogen at this stage. So I think what's important here is that these airports would be considering to support potentially all of these vectors at the same time. And of course, in addition to SAFs and also traditional kerosene aircraft as well, as there'll inevitably be a transition period. So I think that's an important thing to consider, that we have coexisting aircraft operating at our airports in the future. So if we move to the next slide, please. So I talked about the fact that battery and electric aircraft are thought to be slightly smaller and slightly shorter in range. And the key reason for this really is the vastly inferior energy density of batteries compared with kerosene and indeed hydrogen. So batteries are very heavy, and that obviously causes problems for your aircraft and your airframe. So the feeling is that in the next decade or so, because of where we're at in terms of the development of battery technology, we will be looking at a sort of area around sort of 200 to 400 kilometers in terms of range for those aircraft. in the sort of small regional or commuter sized aircraft up to about 19 seats. Now in Project Napkin, we are focusing purely on fixed wing aircraft, but it's also important to note that over time, the development of vertical takeoff and landing, sub-regional and UAM aircraft using electric and potentially hybrid electric technologies are also will be operating in this space. But the focus of Napkin is purely on fixed range aircraft. So if we just move on to the next slide, please. And just to highlight that this is the sector that this is the area where we think that we'll be focusing for the next decade or so, in that sort of slightly shorter range, slightly smaller aircraft. The prospect of anything above sort of the traditional narrow body aircraft, anything over 100 seats for a pure electric or a hybrid electric technology is still quite some way away, we think. So thank you. On to the next slide, please. When talking about electric and hybrid electric aircraft, one of the key questions from an operations and infrastructure perspective will be how we recharge those aircraft. And there seems to be two sort of potential schools of thought in that regard. On the one hand, we have battery charging systems. So this is where the batteries will remain in situ in the aircraft, similar to how we recharge an electric car currently. And the optimum way that we would recharge a battery would be slowly. So the slower you charge a battery, the longer the life of that battery. While it's possible to fast charge batteries, that will reduce the cycle life of the battery and require it to be changed more frequently. So the optimum way to charge an electric aircraft is slowly. But of course, if you're talking about pressure on minimizing turnaround times, that may not always be possible. There's thought to be less need for specialist equipment when it comes to charging batteries that are in situ in the airframe already, similar to the way that we would apply sort of ground power units to an existing aircraft. The opposite way, or the other way in which batteries may be recharged, is via a battery swapping system. So this is where the batteries are actually removed from the airframe, taken away, and then replaced with a fully charged battery. And generally the opposite is true in terms of pros and cons of battery swapping systems. These are likely to be much, much quicker. So potentially almost instantaneous, assuming that you can remove and replace the battery fairly quickly. But of course, that does require, is likely to require additional specialist equipment in terms of ground handling and ground service equipment for removing the batteries and moving them around the airfield, as well as changes to handling requirements and training for ground crew, and also facilities for the storage and recharging of batteries on the airfield. So there is a sort of a footprint question and also a location and safety question around where we might be storing batteries that are being recharged on the airfield. Potentially, there are also safety implications around battery swapping systems, in that you are removing a battery from an airframe, which is thought leading to things like sparking, depending on sort of the ambient conditions and so on. So there are question marks from a safety perspective as well with battery swapping systems, which are perhaps not quite so prevalent with the battery charging, where the battery remains in situ. For both cases, regardless, it is likely that, of course, electric aircraft will increase demand in terms of the draw on the grid, in terms of overall consumption, but also questions around the patterns of consumption and how that links into broader usage of the grid. And also, inevitably, it's likely that we will need to be talking about how to integrate high voltage cabling to support these systems as well at airports. And in some cases, in legacy systems, that can be quite a challenging prospect. So some challenges around the operations and infrastructure from an electrical perspective as well. So if we just move on to the next slide, please. One of the questions that airports will inevitably face with regards to electric aircraft, and one that we are looking at in Project Napkin, is around what would be the charging capabilities in terms of on-stand charging in the ramp-up phase when electric aircraft start to enter the market. So we've been modeling and looking at simulations and scenarios, taking sort of potential charge times for electric aircraft under various scenarios, and then simulating what would that mean in terms of how many stands would need to be fitted with electric charging capabilities. And I think the message that we are seeing with our work and keen to put forward here is that certainly in the initial phases of electric aircraft adoption, where electric aircraft play a relatively minor role in terms of the overall share of the global fleet, airports will be able to have one or two, maybe even 2 or 3 stands that could recharge an electric aircraft, and then phase it as electric aircraft increasingly grow within the market. So it's not a case that suddenly all aircraft stands will have to be able to recharge electric aircraft. The likelihood is that will be able to be phased based on the growth of electric aircraft in the market. If we go to the next slide, please. We then have hydrogen. So hydrogen is quite a bit more complex, I think, than electricity for various reasons. One being the sort of general requirements and considerations that need to be at play when talking about hydrogen. And I've just listed 3 of the sort of key ones, I think, at the top. If we're talking about gaseous hydrogen, this will typically need to be supplied, stored, and delivered at high pressure. It's much more, as Adam showed in his presentation, the volume of gaseous hydrogen is much greater than the equivalent kerosene, so it needs to be under high pressure. Liquid hydrogen, on the contrary, requires cryogenic cooling to very, very low temperatures. If the temperature rises above minus 253 degrees Celsius, the liquid hydrogen will evaporate and boil off, so you'll lose some. So there are problems there in terms of cryogenic cooling of liquid hydrogen. And depending on how the hydrogen is delivered or supplied and how it will be delivered to the aircraft, there may be a requirement either for liquefaction, which is turning gaseous hydrogen into liquid hydrogen, or in the opposite direction, vaporization from liquid to gas. And that has both an infrastructure challenge, but also in terms of energy demand as well, certainly if that's taking place on the airfield itself. The figure shows sort of 3 potential options with regards to the supply chain of hydrogen to the airport. The first of which is actually one which we don't think we will be seeing in the very short term. We think this is where you will have on airport sort of generation of hydrogen via electrolysis on the airport. That's likely to be more relevant once the technology is far more mature and hydrogen aircraft play a much greater role. We don't see there being a business case for airport operators to be investing in electrolysis and hydrogen generation technology in the short term, at least. What's more likely is options 2 and 3, where you have off-site generation of hydrogen, both in its gaseous and liquid form, and they are then transported to the airport, either by road, via trucks, via train is possible, or even by sea in some cases. So we can see the transportation of hydrogen to airports using a variety of different surface transport means. Once on the airfield, you have storage requirements. And what we are seeing certainly in the sort of initial phases is that hydrogen could be stored in trucks or trailers or in tanks. So specialist tanks for storing hydrogen. There are question marks around where these can be located and how they could be co-located with kerosene storage and sort of traditional fuel farms and fuel storage, as well as those questions around leak detection, boil off of liquid hydrogen and so on. So tanks that are cryogenically cooled, warehouses that are well ventilated and so on if it's gaseous hydrogen. All these questions come into play with regards to hydrogen storage. When it comes to the delivery of the aircraft, similarly, there are different options. We can have containers being swapped in and out of the airframe, so specialist gaseous hydrogen containers to be swapped in and out. We can have it delivered by truck or by trailer. So there are different ways that this can be delivered depending on the aircraft and also the airport infrastructure as well. There are pertinent questions that we are looking at here in terms of technical capabilities around things like leaks and embrittlement of sort of fuel hoses and GSE and storage equipment, but also the overall stand layout and airfield configuration and design of airports to accommodate these different operations and processes. So if we just go to the next slide, please. The question that we are looking at now in Napkin, and the basis of a lot of the work that we're conducting, is looking at scenario planning for hydrogen storage and delivery. So the manufacturers and other partners on the project, indeed Rolls-Royce, are putting together aircraft concept designs. So the one that we have here is based on an ATR 72 platform, and it's a liquid hydrogen aircraft, which is using hydrogen as a direct fuel source. And what we've been doing is generating scenarios. So envisaging that these aircraft would take the place of existing aircraft flying on domestic routes. So the example we have here is from London City to Jersey. And we've been saying, what if this route will be served by a liquid hydrogen aircraft? And then scaling up what that would mean in terms of the requirements for, in this case, London City Airport, but we've been doing it for other airports within the UK as well, just to get a handle on what kind of supply, storage and delivery requirements would be the case as liquid hydrogen and other aircraft types sort of enter the market through time. So that's the sort of the focus of the work currently. If we just move on to the next slide, please. So I'd just like to conclude then with three thoughts, really, three sort of light-hearted thoughts, but just to end on, and some of the key messages that are coming out from our work in Napkin. I think there is a tendency when talking about different technologies like this to sometimes be drawn into seeing them as competing technologies. And I think certainly the message from us is that it's about finding the right tool for the job in hand. It's not a case of trying to pick a winner or deciding which energy source is better or will win in that sense. We see that things like pure electric and aircraft could be very useful for things like general aviation and pilot training. So it's not a case that battery technology is doomed and it will never work. It's about choosing and picking those technologies so they can coexist. So it's all of those things rather than picking one. From an airport operation and infrastructure perspective, one of our key focuses is trying to make sure that these technologies can be integrated with as little disruption as possible. So, of course, there will be some changes to airport operations and infrastructure with these new technologies, but if it can be incorporated in a way that looks fairly similar to what we have currently, that's really a good thing. I think there is sometimes a surprise that we're not looking to completely reinvent the system here or make something that looks very different or operates in a very different way to what we have currently. The idea is that we can integrate this in a way that's as seamless as possible. And just a last sort of point to think on, I think, that to make zero emissions flight and zero emissions technologies a reality, it's not purely a technical challenge. Of course, there are significant technical hurdles that do and are being addressed, but there are also very important questions, crucial questions around certification, around safety, and around passenger perception as well. So ultimately, passengers will have to want to fly on these aircraft for them to be successful. So there are all these kind of questions that need to be addressed in addition to the very important and prevalent technical issues as well. So thank you very much indeed. That concludes my presentation, but of course, I'd be very happy to take on any questions or comments from the floor. So thanks, Fiona. I'll hand back to you.
Thanks, Tom. That's much appreciated and so interesting to see that and to see the work that's been done in Napkin also. I've got a quick question. I'm going to ask it just now rather than maybe keep it to the end, if we can sort of keep the answer quite brief if possible. It's from Mirza, who's watching, who's asked, out of your three supply chain models, which is most likely to be adapted in the long run, in your opinion?
So, classic sit on the fence answer. It will depend. I think in the short term, initially we will see options 2 or 3, where you have off-site generation of hydrogen to be then delivered to airports. And I think in the immediate term, that can be developed and delivered using road transport. So trucks just trucking and trailing hydrogen into an airport, as you would do for other sources of fuel. I think as the technology develops, that is where the case may be for on-site generation of hydrogen potentially. But we don't see that being the case for quite some time yet. There just isn't the case for the quantities of hydrogen that you would need if you were generating it on site. So I think in the immediate term, or when hydrogen first enters the market, 2 and 3, but later on potentially option 1 would be my feeling.
Okay, thanks a lot, Tom. And great to see that 2/3 of our airports are planning for zero emission fuel that are watching today. So that's really encouraging to see. Okay, we're going to move on now to our next speaker, who is Valentina Vecchio, a lawyer by education. She was appointed as the regional lead for sustainability policy and partnerships in Europe in April 2021. She's also been responsible for representing Boeing with various European institutions in the fields of environmental and chemical regulations since 2018. So I'm going to hand over to Valentina now.
Thank you. Sorry, I started sharing and forgot to unmute myself. Apologies for that. So let me share my screen. And in the meantime, thanks again so much for having us here today. We're really happy. I'm really happy to be part of this dialogue and to join my fellow panelists. Confirm just that you can see my presentation and all is running smoothly before I dive into it. All good? So what I would be happy to share with you today is our vision for sustainability, and also explain to you a bit how we see sustainability at Boeing and how sustainability and innovation are really interconnected for us, as sustainability represents a way to advance greater innovation in aerospace. But first, let me take a step back and reflect on the important role that aviation plays as a social and economic engine in our society. I think especially coming out of a pandemic, we have seen how important and how crucial the role of aviation is to build bridges across communities around the world, whether it was for transporting medical equipment and then vaccines, but also maintaining global supply chains. Aviation has really risen to the challenges of a global pandemic, bringing the world together. And of course, this role as economic and social engine comes with a responsibility to not simply grow, but I would say earn our license to grow sustainably. And sustainability at Boeing encompasses environmental stewardship, social progress, and value-based transparent governance of our company. In the midst of the pandemic, we appointed our first Chief Sustainability Officer to guide our transition and vision of sustainable aerospace across environmental, social, and governance perspectives. And not only sustainability starts at the top, but it also has to be embedded in the way we run our company and we impact communities around the world. And this is why we embed sustainability in the way we build our products and services, and we work with our employees, our communities, and also across our supply chains. You see here our pillars from people to communities, operations, and products and services. It's important to embed sustainability in our global community, which comprises different employees with diverse backgrounds, but all united around the common goal of advancing aerospace innovation. And then we look into sustainability when we build products and provide services, considering the full life cycle of our aircraft, from design and production to operation and end of service retirement. And then, of course, we give back to communities and invest in education and training. And also we look into our operations and drive greater sustainability to source responsibly across our supply chain. And now to dive a bit deeper into sustainable aerospace and our vision. Adam talked about 3 pillars. At Boeing, we have a 4th pillar, but I see great alignment in the work that we are doing all together to advance sustainable aerospace in the decades to come. Fleet renewal is definitely an important part of the work that we do, as new airplanes provide significant efficiency gains, with each generation reducing fuel use and emissions between 15 to 25%. And at Boeing, we have have been investing over $60 billion over the last 10 years in several areas, from aerodynamics to composite materials and more. And then operational efficiency is also extremely important, and we develop many services to leverage data for fuel efficiency and help our customers optimize flight planning by providing pilots with real-time data and information to optimize and identify the best flight routes to save fuel. And then also accelerating renewable energy, which is crucial inside our four walls for our operations, but as well as in our products and services. And that renewable energy can range from sustainable aviation fuels to green hydrogen or batteries. And then advanced technologies, thinking of what the future of air travel looks like and thinking of the next generation technologies. And when I look at these four pillars, there are a few things that I really want to stress. First of all, that probably there is a fifth pillar, even the pillar of collaboration, that really underpins all the actions that we are taking. This is not just the Boeing strategy, it's really what we're doing with stakeholders across the entire aviation value chain. And then that also we need to think of different levers, that there is no silver bullet, but we need to think of things we need to unlock today. And one example is sustainable aviation fuel, as well as tools for greater operational efficiency. At the same time, look into the future of air travel and work today on tomorrow's technology. So we need to operate in different timelines at the same time. And so looking a bit more into today's action, sustainable aviation fuel is definitely maybe the silver bullet that we already have today. It's already in regular use and offers the most immediate and largest potential to reduce carbon emission in the coming decades across all aviation segments. It can be blended directly with conventional jet fuel so that no modifications are required to airplanes, engine, or fuel infrastructure. And we have been pioneering the use of sustainable aviation fuel from day one, from the very first test flight in 2008. And then in 2018, our EcoDemonstrator program flew the world's first commercial airplane flight using 100% sustainable aviation fuel on a 777 freighter with FedEx. And most recently, in January 2021, January this year, we have announced that we want all our commercial airplanes to be capable and certified to fly 100% sustainable aviation fuel by 2030. This is a necessary goal to advance the long-term sustainability of commercial aviation. And you probably already know that the maximum allowed today in the current fuel specification is a 50-50 blend. So we're committed to working with regulators, engine partners, and stakeholders to ensure that our airplanes can fly entirely on sustainable aviation fuels. And so part of this work is also overcoming obstacles to scaling sustainable aviation fuel. And just a few months ago, we took steps in that direction, teaming up with Sky Energy and Sky Energy's Americas to scaling the availability of sustainable aviation fuel globally, and also invest in their new production project in the Pacific Northwest. And now a look into tomorrow's technology and the work that we are doing, which is concurrent to the work on SAF, sustainable aviation fuel. We're also exploring new technologies for different aircraft sizes and market segments, including hydrogen fuel cells for powered flight and onboard power, as well as battery-powered flight, a new highly efficient truss-braced wing concept that you see here, all represented in one chart. Particularly on green hydrogen, we have been working on green hydrogen and fuel cells applications for over 15 years and have developed key learnings and insights through different flight demonstration programs with both crewed and uncrewed aircraft and using hydrogen fuel cells and combustion engines. And the insights that we have gained from those studies are now informing future partnerships and future research. The aviation community as a whole, in fact, needs to develop not only the propulsion technology itself, but also the infrastructure for production, storage, handling, and delivery, as Thomas brilliantly explained just now. So there's a lot of work going on and exciting work ahead of us. And then, of course, there's also the work that we are doing on electric aviation, particularly through our partnerships such as WISC, which is a joint venture between Boeing and Kitty Hawk to develop, test, and certify all electric vehicles. These are particularly aimed at market segments that can reduce urban congestion and emissions from vehicles on the ground. And what you see here is Cora, a 2-passenger eVTOL air taxi that we are developing with WISC and has already flown more than 1,500 successful test flights since 2017. And then what you see here is also another design, another program that we are working on with NASA's Subsonic Ultra Green Aircraft Research Program in order to explore and develop advanced concepts for advanced aircraft. And you see here the key areas that we are researching on, particularly on enhanced aerodynamics and feature next generation combustion technology, as well as stronger, lighter, and efficient manufacturing of carbon composite wing, and also a thinner and more aerodynamic wing that can burn less fuel per flight. And I would like to conclude talking about yet another program, but I think probably the best ambassador of the importance of working to advance sustainability in aviation through collaboration. And this is our EcoDemonstrator program. The EcoDemonstrator program is literally a flying test bed that takes technologies out of the lab to test them in the air. And the 8 aircraft that you see here over the years have served as EcoDemonstrator since 2012 and tested several technologies, over 170 projects ranging from sustainable aviation fuels, landing gears to lessen noise, as well as ways to improve aerodynamics, and also new cabin disinfection tools. This just gives you a sense of how the program can adapt to the challenges of air transport by providing new solutions. And particularly this year, we have announced our 2021 EcoDemonstrator in partnership with Alaska Airlines, and the test flights have already begun and will end around early December. And the EcoDemonstrator this year is testing around 20 different projects, in particular a new halon-free fire extinguisher agent that can significantly reduce the impact on the ozone layer, and also different designs to reduce noise, as well as cabin sidewalls made of recycled materials. But really the main point here is to stress how important it is to team up and partner across the aviation value chain, and particularly as we approach a green recovery for our sectors, the importance of sustainability is definitely there to stay, and we need to team up to achieve even more ambitious goals. So I'll stop here and give the floor back to Fiona for any questions.
Thank you, Valentina. I had the privilege of being able to experience the EcoDemonstrator at Glasgow last month at the Boeing Innovation Forum, which was at our airport, which was absolutely amazing to see. So great initiative. If anyone gets the chance, it's certainly something to see. The Boeing's target's 100% SAF by 2030 is obviously an amazing target to be working to. I just wondered, quick question on the sort of regulatory route to that, in particular with regards Europe versus other parts of the world. How would you contrast the legislative proposals that are in play at the moment for that on SAF?
Yeah, that's really an interesting question, and I'll keep my answer short, but I would say that in general, policy is definitely a key component to advance SAF, particularly because now we're in that stage where we need to make sure, because the technology is there and it's mature, we need to cross that valley from having a technology that is technically feasible to actually having it commercially viable. And policy has a key role to play. There are actions that both the European Union and the UK have taken, whether it's with blending mandates, but also the green fuels, green sky competition, and most recently the EU also announced a potential new alliance on renewable fuels for transport. Those are great initiatives. And then of course we have the steps that the US has taken already, particularly in California, which are great examples of ways to incentivize production. I think in general with policy, there's no one size fits all. You need to find what works best in the market, but we need to definitely scale it up. So there's more work ahead of us and key work with regulators.
Absolutely, policy is so key in all of this. Thanks so much, Valentina. Great presentation, really interesting topic. And hopefully we can ask some more questions near the end. So I'm going to move on now. Thank you. So to Peter Rafano. Peter spent 17 years as the operational noise and airspace manager at Heathrow Airport, working with stakeholders including UK government, airlines, NATS, Eurocontrol, and probably, I'm sure, many others to manage aircraft noise. He joined Envirosuite in 2020 and now uses his long-term experience to help airports around the world manage their environmental issues. So I'm going to hand over to Peter now.
Thank you very much, Fiona. Just checking, can you see my first slide there?
Yes, we can, Pete. Thanks.
Great. Thank you. Thank you. And good afternoon, everyone. 3 fantastic presentations so far today. And now I'm going to spend just a few minutes and present a case study on how Heathrow Airport is using one of our products called ANOMS carbon emissions to accurately track and report upon aircraft emissions. But first, before I do that, I thought I'd just give you a little context. So, as we're all very aware, aviation carbon emissions is an issue that's being tackled by multiple organisations across the globe. The EU has its Destination 2050 programme, which aims to improve ATM and aircraft operations to achieve emission reductions of around 6%. The FAA has its Sustainable Airport Development Programme, which has 4 themes, one of which is sustainable operations. ACI has called for a global effort to tackle climate change, and closer to home, Sustainable Aviation has committed to a 50% reduction in emissions by 2050, while allowing for a doubling of flights in that time. So these are all hugely ambitious programs and reflect the scale of the threat facing the industry. Heathrow's launched its Target Net Zero plan, leveraging its position as a leading global airport to help aviation get to net zero carbon by 2050. Chief Exec John Holland-Kaye has rightly stated that carbon is the enemy, not aviation, and Envirosuite is helping Heathrow in that fight. Indeed, Heathrow has already reduced emissions from its operations by 90% and has committed to zero carbon airport infrastructure by mid-2030 and is working to deliver net zero operations overall by 2050. The airport is currently at level 3 carbon optimization with the airport carbon accreditation scheme and is working towards level 3 plus, which is carbon neutrality. Carbon optimization level requires scope 3 emissions to be taken into account, and this includes aircraft takeoff and landing cycle emissions, and it's where our product comes in to help. Heathrow has limited direct control over most of the carbon emissions in its carbon footprint, which come mainly from its airline partners. Therefore, its plan is to use its leadership position to accelerate the era of sustainable flight. And to do this, the airport needs detailed insights into the entire scope of aircraft emissions, both airborne and on the ground, and they're using our ANOMS carbon emissions product to give them that detail. So, how are we supporting Heathrow in their carbon reduction and reporting ambitions? So the story begins back in 2013 when a product called AirTrack, which is now rebranded as ANOMS carbon emissions, was deployed at Heathrow to the then Air Quality team. As the operational noise manager at the time, my role was to ensure that all the airborne tracks that were a key component of the noise and track keeping system at the airport were all being accounted for in carbon emissions, thereby ensuring that every flight was being fed into the new carbon reporting system. At that time, Heathrow looked for a detailed breakdown of carbon emissions to help them drive management KPIs, effectively engage with airlines and other stakeholders, understand the benefits of any initiatives the airport may implement, and of course, accurately report upon emissions. And at that time, the air quality team required some enhancements to the product. They asked Envirosuite to deliver weather-based adjustment of fuel flow, use of the holding zone data from the airport's noise and track keeping system, and to add multiple fuel types, including sustainable aviation fuel. And after a period of extensive testing that ran for over a year, those enhancements were delivered and the product ran without any further changes until 2018. Now, in that year, working with Envirosuite, Heathrow delivered an airfield ground tracking system for aircraft called OPAS. And this allowed actual ground tracks for each aircraft to be fed into the carbon emissions product alongside the actual airborne tracks they already had. This removed the need for standard taxi time calculations, which have been shown to overestimate emissions by up to 30%. Additionally, Heathrow began to capture reduced engine taxi data, and a different calculation was made in the product for individual flights that were using that practice. And in 2021, the product was further enhanced to include actual passenger data on a flight-by-flight basis for emissions per passenger kilometre reporting, and the en route phase to destination airports was added as well. So CO2 per passenger and CO2 per passenger kilometre are extremely useful for disaggregating the positivity of recovery and resulting absolute carbon increases from the improvement in aircraft and operational efficiency. These metrics are speaking the same language to airlines. They often use these measures for their own target setting. So Heathrow had the product independently audited following the latest enhancements, and is now using the carbon emissions product for carbon reporting. So before my final slide, a little bit of background on Envirosuite. We have over 500 customers around the globe and have been providing environmental monitoring solutions to Heathrow for well over 2 decades. We're a publicly listed company on the Australian Stock Exchange, and we're a world-leading provider of environmental intelligence solutions. We provide real-time monitoring and predictive technologies for weather, air quality, dust, odour, noise, and of course emissions management. And we provide systems to clients that allow for continuous monitoring, predictive modelling via a managed service, and we provide actionable insights and data beyond question. So how are we providing this easy and accurate assessment of real aircraft greenhouse gas emissions to Heathrow? Well, as I mentioned earlier, we use our airborne and ground tracking systems called ANONS and OPAS to track each flight arriving and departing Heathrow across the entirety of the LTO cycle. Using our systems, Heathrow has the ability to understand where and when any aircraft was using the airport from stand to 45 miles distant from the airport. We can calculate the length of the aircraft track using the time of radar points to determine the duration of any phase of flight. The data is then split out into the various phases of flight required for carbon reporting, as you can see on the slide there. Having the individual track data means the data is fully auditable right down to the individual flights that make up the calculations. We have actual measured times in mode for every phase, and we do not use models. We can also include a percentage of sustainable aviation fuel as well, as these new fuels come on stream and become further adopted. Indeed, by creating a new configuration with an increasing amount of sustainable aviation fuel, the airport can see the positive impact that increased SAF take-up would have on its greenhouse gas emissions. The data can be easily broken down into any combination of airline, aircraft type, domestic or international service, or by the greenhouse gases, CO2, NOx, or H2O. It's extremely easy to use, more accurate than standard ICAO times, and means Heathrow can measure the effectiveness of any carbon reduction measures they might wish to put in place. The environmental team gets a greater detail on who, where, and what, and that allows a better understanding of operations and the effectiveness of any initiatives that they're running. ANOMS carbon emissions allows Heathrow to effectively report in a monthly reporting cycle, and the data is easily exportable for presentations or Excel for further analysis. And once set up, reporting is totally automatic. The system requires very little housekeeping, only the addition of new aircraft type as they come on stream, and allows Heathrow to capture detailed insights by phase of flight, by airline, or by aircraft type. Finally, the successes of any initiatives the airport deploys can be assessed quickly, allowing for adjustments to be made. Thank you for listening. That concludes my presentation. I'll hand back to Fiona.
Thanks, Pete. Thanks for that. Really interesting and great to see the work that you've been doing with Heathrow and a little bit about the tools that you have and that you supply to airports. So my question would be, I guess UK airports maybe would know Envirosuite first and foremost for your kind of work or your offerings for managing noise, maybe initially. Do you see a renewed or a new interest or increased interest from airports now on monitoring carbon? Is that, and how much of a sort of step change do you think that is?
Yeah, I think from an airport's perspective, from an aviation perspective, we can all see the threat carbon has on the industry. More and more airports are increasingly concerned about carbon emissions, want to get a handle on exactly what their carbon emissions are. And a product like this helps them get a handle on exactly what they're doing, any initiatives they wish to put in place, and the effect that those initiatives might have on their carbon emissions. In terms of your first point, yes, there is now a definite step change, I think, between carbon and noise. Some of the communities around the airports will still be more noise focused, but I think the wider general public and indeed the aviation industry is switching its focus or adding additional focus maybe to carbon.
Thanks, Pete. Well, according to our poll, there are 40% of our audience today who are not aware of their Scope 3 emissions from aircraft or not quite sure of them. So there's obviously still some airports who could benefit from some support in trying to understand that. So that's really interesting. But thanks again, Pete. That was really great to see your see a little bit about the offering from Envirosuite. So I'm going to move on now to our final speaker, who's Will Wright. And oops. Will is currently an A320 family pilot. He's the chair of the Young Air Pilots and an Aviation Human Factors Master's student. He's an aerospace engineering degree under his belt, as well as considerable exposure to the industry, which puts him in a strong position to contribute to the sustainability agenda for his age group. So I am really, really interested to hear Will's take on sustainability. So I'm going to hand over to Will now. Great to have you, Will.
Hi, Fiona. Hope you can all hear me, and thank you very much to both you, the rest of the panelists, Aviation Events Group. It's strange. I've got a bit of imposter syndrome sat here amongst such esteemed guests, both with the conversation today, but over the 3 days that you guys have the event on and the duration of COP. But it really is a pleasure to contribute to the conversation. Let me see if I can get my presentation up, and hopefully you guys can all see that. What I want to start off by saying is what I'm not. Thank you for your kind words again, Fiona, introducing me. But what I'm not is an expert in the field of advanced technology, sustainable fuels, achieving net or jet zero or carbon reduction in itself. But what I am is a 320 pilot flying across Europe. I'm based at Glasgow, which is obviously an AGS airport. I work for one of the most sustainably focused airlines in Europe. We like to think, like you said, an engineering degree. I've got experience in finance. Currently doing a human factors degree. And I suppose why I'm here is as the chair of the Young Air Pilots, which is within the livery company of the Honourable Company of Air Pilots, who recently had their Green Aviation event, which is bringing to bear UK finance with government, the aviation sector and academia on sustainable aviation. What I also am is a millennial, but I'm passionate about inspiring the next generation, whether it be to improve their resilience, to get them on the first ladder into aviation, or to encourage them to think more sustainably. So that is why I'm here, and I'm very pleased to be here. What I would also add from those two things, I did a year in industry with Rolls-Royce, so it's great to see the Ultrafine making an appearance today. I used to work in combustions and castings on the Trent XWB engines, so yeah, fabulous to see that. So first and foremost, the generational change, I suppose, is the first thing that I want to mention. There's obviously been a considerable change over time, and possibly in the last 100 years, we haven't seen change like it. I was listening to the presentations yesterday, and someone came up with a stat that in the 1850s, you had a 50% chance of being in poverty, and the average sort of age expectancy or life expectancy was 41 years old. I think that we can safely say that has changed considerably. And the key points there on the right-hand side is that we now live in an age of information. We have a greater social conscience of Generation Z and beyond. We have an abundance and an ability to make choice, and we're influenced on a mass scale. If you think about your phones constantly being pinged, it's wonderful being able to be connected to everyone, but often leads to influences that may be beyond your control, as it were. So with that sort of backdrop, I want to move into the sustainability pillars, if you like. So we are currently talking today within the middle pillar, the environmental pillar, the achievement of net zero, jet zero, within aviation. But what is also important within the context of my generation, I think, is the other two pillars, which is the social and the economic. I think COVID now more than ever has shown that our generation, people want a balance of the biopsychosocial element of life, whether it's life quality or achieving work, but also achieving playtime and rest as well, and the well-being, the mental health and resilience all come into that. Furthermore, they're looking at economics of what they want to do. Do they have longevity? Do they have security in their chosen career path? And finally, environmentally, they want to be involved in organizations that really have values that align to theirs and that really go out there to make a difference. I was reading some stats that we'll also come on to in the polls later on, but apparently 9 out of 10 millennials believe that private individuals as well as businesses have a responsibility to achieving sustainable aviation. But only 4 out of 10 are willing to make that change by changing their own personal behaviours and purchasing behaviours, which I think is quite interesting. I'll move on to what I believe is a disconnect. Clearly, we've seen that my generation is sustainably focused. They care about their values and their morals and having a balance of life. But what the literature is telling us, and also anecdotally that I've found, is that although they have those values, those inherent beliefs, they seem to be a lack of wanting to make a difference. And I hope that Jen and the team and Andy have got a poll up somewhere, which is percentage of millennials that believe businesses focus on their agenda rather than society at large, and what sort of percentage that you guys think that is. I'm going to try and bring up the rest of the screen. And whoops. And hopefully we'll have the results. I think I'll leave it on for a couple more minutes. Oh, poll's not running properly. Okay, not a problem. We shall move swiftly on. Always the technical benefits of these sorts of things. What I would say, actually, just sticking on that, during this research, there were many stats that I found, but the vast majority back up this point that although we might be the most socially conscious generation, we lack sort of the motivational drivers to actually do something about it. Hopefully, and the point of this discussion is that I really believe that should change, and we should really put the focus on the next generation and really empower them to be able to make change. And what I'll do in this context is talk about pilots, because that's what I know most, but also maybe aviation stakeholders. So prospective pilots, where are they now? They're probably kind of finishing school, university, college, almost certainly passionate about aviation. I was at PCL, Pilot Careers Live, which looks at recruiting the next generation of pilots just last weekend. And it's quite clear that although they are passionate, they're thinking about different options. You know, are they looking at transferable skills or routes into flying? They're thinking about what we call the pilot in command mindset, how they can be engaged in aviation and really networking within that space. What they actually are concerned about is, can I actually make a career out of aviation? Will my terms and conditions be eroded? Is there even going to be an industry to enter? And that can also be seen with current pilots. There are large career threats we talk about in aviation, the cyclical nature of the beast, whether it's COVID, single pilot operation there, perhaps financial difficulty or ruin, circa sort of 2008, 2009 coming back. Even things like losing medicals and potentially sustainable aviation in itself is possibly a threat. There was a quote that came up yesterday again by Gene Gabolis, I think his name is pronounced, which is grow as you shrink, which I think is a really interesting concept. It's sort of how do aviation stakeholders and businesses and industries, how does it grow whilst reducing their carbon footprint? And does that represent a threat, an existential threat to aviation? Will aviation itself shrink, and therefore the need for pilots and my current job be null and void at some point in the future? And then there's the question mark, the unexpected. Who knows what other threats there might be? But it's all plays into the same melting pot of what current pilots think about their future. Then we talk about the other stakeholders, because of course we're not just talking about pilots within aviation. There's air traffic control, there's engineers, there's ground management, there's management itself, there's regulators, there's government, there's all sorts of different individuals and stakeholders within this industry, and we need to see it flourish, and we all need to pull together in order to achieve net and jet zero by 2050. So how do we do that? Well, I've taken the little screenshot from the Jet Zero consultation there on the right hand side, and as a few people have said today and yesterday, there's no silver bullet. It's going to be a plethora of different to all pull in the same direction, hopefully. But what is important in the context of what I want to talk about is that we really have to engage the people now and the future generations in order to achieve them. The next generation is sort of today's entry-level employee, if you like, but definitely tomorrow's decision makers and change managers. Finally, coming on to how then. So within the context of those four pillars, which I've pulled out in a slightly different way, we talk about operations, infrastructure, and markets, and technology and SAF. I've just put together a few thoughts about what I think we can look at as a collective. So I'll let you just sit there for 2 minutes and read those. Now, what I would say is that I don't have all of the answers. These are only a few that I've sort of thought of myself. But what I would welcome is conversation with any of our panelists today or any of our attendees on how that might be achieved. And within the context of the Young Air Pilots and the Honourable Company of Air Pilots, if there's anything that we can do to help you and vice versa, I'd be very open to any and all conversation. And finally, I just want to leave you with a thought. I believe that we need to engage the next generation on sustainability and really motivate them to act towards change. Net zero by leveraging inherent social conscience and technological familiarity. I hope to do that by myself, by going out there and doing some outreach activities, by using my own personal operation in my airline to set example. But I'd like to hear about what you guys think. I've had poll results come through. So the first one: what percentage of millennials believe that businesses focus on their own agenda rather than society at large? 60% went for 65% and 40% for 75%. So it's actually 75%. So a really quite high percentage of people, I think. And the final one: what percentage of millennials think that businesses have no ambition beyond making money? And most of you got the right answer there. So 67% of you are correct. It is 62%. So with that said, and so that's an interesting bombshell to end on. I'll pass it back to Fiona. And thank you very much for your time.
Thanks, Will. That was really, really interesting. And thank you for some of the stats as well to give us some of that insight. I'm going to ask you just a question that's in my mind. So bearing in mind the results of that poll, where there's quite a high percentage of millennials who believe that the industry or businesses are really just all about, sort of capitalist approach. They're all about making money. For the aviation industry in particular, if there was one area that we could focus on to try and change that perception or to try and encourage young people into our industry, where should we be focusing our efforts?
Yeah, so that's a really interesting one. I think you've got to go to where the millennials are, right? So they unfortunately they tend to be on the social networks, the likes of TikTok, the Facebooks, the Instagrams, whatever it might be, the next generation of social media. We have to really engage them in the forums that they're already engaging with. And I think that's already been proven in the past, the sort of mass psychology and being able to influence people on a mass scale. That if we start to put interesting content out there that shows the benefits of what we're doing and why we're doing it, then I think that's the best place to be.
Yeah, great answer. It's so important to try and feed that pipeline for the industry. And I mean, my feeling is really that it's an opportunity. It's a lot of people are sort of seeing it as a threat. That aviation is as a polluter, and that's the kind of narrative. But there's a definite opportunity in all of this, in that we can change the way that we do business and really use that to our advantage and truly make a difference and use that to encourage younger people who are socially conscious into our industry with all these sort of really interesting new innovative ways of traveling as well. So it's quite an exciting time ahead, I think, and it would be great if we could sort of embrace it as such. So thanks so much, Will. That was really, really interesting. And thank you to all the panel speakers. Just a couple of questions for discussion before we finish the session today. So just on the sort of theme of opportunity and with sustainability, in terms of employment, do the panel believe that future sustainable aviation, how will it bring more jobs to the industry? Will it change the landscape? I'm sure it'll probably do both, but just keen to hear if there's anyone in particular who has a thought on how it might change the employment landscape for the aviation industry. Maybe from one of the airlines or engine manufacturer?
Yeah, I'm quite happy to answer that. Through sustainable aviation, Rolls-Royce is aware of work that's been done to look at the potential implications of a subset of investment in SA, and that's investment in SAF. And one of the things that we're confident about is that investment in sustainable aviation and delivery is an important part of effectively providing a credible and robust route to net zero. And it's that robust and credible route to net zero which ultimately not only protects existing jobs, because it as we come out of COVID, people are much happier to continue or to start flying again, but also is likely to be key to allowing, coming back to the point made by Will, the growing whilst you're shrinking. I think it's going to be a key part of allowing expansion in passenger kilometres in the UK, and hence the growth in the infrastructure and the carriers that ultimately deliver that. And more widely, sustainable aviation, for work done by the organisation Sustainable Aviation UK, has identified other job opportunities, certainly in the SAF clusters around the country, whether that's South Wales or Scotland or the South Coast, or places like Immingham and Humberside, and in some cases absorbing people who lose their jobs in other areas of industry because of decarbonisation, whether that's the North Sea or refineries, etc. So yes, absolutely, SAF alone, I think, can not only protect jobs in aviation but also helps to create them in other parts of the economy.
Thank you, Adam. Yeah, that really resonates. Thomas, did you have a thought on that from your perspective?
Thanks, Fiona. Yes, I think we are already seeing and will continue to see an evolution in the job market and across the sector. I think in some cases they will be specialist roles that are created across the supply chain relating to the technologies themselves. But also I think you will also see the development of new market opportunities. So things like secondary and aftermarket opportunities for used batteries, for example. Where do they go after they've been taken out of an aircraft? Do they go into other markets? So I think you'll see an evolution in that sense. But also a sort of upskilling of existing roles to reflect changes in technologies and different sort of greater focus on sustainability, including of sort of ground crew and ground operators, ground handlers, changes to fire and rescue provision for people, fire and rescue teams looking at hydrogen aircraft, for example. So that's certainly something that we're looking at Cranfield. And there's obviously a role for sort of academic programs, I think, and education to make sure that that next generation that Will is talking about are prepared for that job market when they enter it.
Thanks, Tom. That was great. And unfortunately, we've run out of time. So thank you to all of our panelists, to Adam Morton, to Dr. Thomas Budd, to Valentina Vecchio, to Peter Rafano, and to Will Wright. It's been a pleasure to chat to you today and to see your presentations. So thanks again for your time and for your presentations today. Just an announcement for tomorrow. So tomorrow is the final session from this series. We have Scott Carey from Ports and Airports, Project Manager, National Renewable Energy Laboratory. We have Sergio Fernandez, Director, Airport Passenger, Cargo and Security for IATA. We have Holly Gregg, who's Deputy Director, Aviation Climate Change for Department for Transport. Julia Scavuzzi, Senior Director, Sustainability, Environmental Protection and Legal Affairs for ACI World. And Gonzalo Velasco, Business Plan and Innovation Director for Ferrovial Airports. And that session will be chaired by AGSO and Brian McLean from AGS Airports. And that session starts at 2:15 GMT tomorrow. So hopefully we will see you all there. just big thanks again to all our panelists and to everyone who's watching. See you soon.